Before starting with this topic, let us understand the meaning of the word interface. Interface means the path of communication between two components which are connected in a system. So it is a communication path, we can say, between two components. So if we talk about interfacing, interfacing will be a technique by which the two components they are communicating with each other. So here we will study that how the input output devices they are interfacing with the 8086 microprocessor. So if suppose this is our microprocessor, we have input and output devices. So 8086 microprocessor, it is going to get the data from the input devices and it is going to send the data to the output devices. So it is communicating with the external world. This is its external environment through the input and output devices. Now there are many ways in which the 8086 it can communicate with the input and output devices. Let us see that what are these ways. So the data is transferred from or to the input output devices and the microprocessor. Now this data transfer it can be done in three different ways. These are program controlled input output. So the three ways are program controlled input output, interrupt program controlled input output, and hardware controlled input output. Or we can say that we can divide it into software and hardware. Software part means that it is program control, and second hardware part is the hardware controlled input output data transfer. Now, let us study that how in these three ways we can transfer the data. In the program controlled input output, because in program we write the instructions. So with the help of instructions, the data transfer is taking place. Whenever we want to get an input data or to send some data to the output device, we will have two instructions in and out, and these instructions will be used to transfer the data between the input output device and the microprocessor. So we are writing the instructions in the program. That is why it is known as the program controlled input output. So in program controlled input output, the data transfer, it is completely under the control of the microprocessor program, the program which is written in the microprocessor containing the input and output instructions. So that data transfer will take place only when the instruction is executed. Okay, and these input output transfer instructions are in and out instructions. The next type of data transfer technique was interrupt program controlled input output. In this, the device, the input output device, it is going to send an interrupt to the microprocessor. Microprocessor at that time, if it is executing any instruction, it will complete the execution of that instruction. Then it is going to access that input output device. It is going to transfer the data to the devices. So in this, we are sending the input output devices, they are sending an interrupt request to the microprocessor. So in the interrupt program controlled method, an external devices, it will indicate the microprocessor that it wants the microprocessor to communicate with it. It wants the data transfer to take place. So it is going to send an signal which indicates that it is ready for the data transfer by sending a signal to an interrupt input pin of the microprocessor. So an interrupt request will be given to the microprocessor. Microprocessor will send an acknowledgement signal that it is ready for the data transfer. It is going to jump at the memory location where the interrupt service routine is written, and then it is going to execute that service routine. So in the form of an interrupt, the request is given to the microprocessor for the data transfer. Next, we are having the hardware controlled input output. So in hardware controlled input output data transfer, the transfer takes place directly between the input output device and memory, but not through the microprocessor. So through the microprocessor, the transfer is not taking place directly. The memory will be accessed by the input output device. That is why it is also known as DMA, that is direct memory access. So directly the memory will be accessed by the input output device. The data will be read from the memory or written into the memory. Only the microprocessor, it is going to provide the starting address plus the number of bytes, that how many number of bytes are to be read or written from the memory. Okay, so these were the three ways in which the data transfer can take place between the microprocessor and the input output devices. Now in this video, we are going to study in detail the program controlled input output interfacing technique. So there were three techniques available, and out of those three techniques, here we are studying the first technique, which is the program controlled input output interfacing technique. In this technique, the microprocessor, it uses the two instructions in and out. So we can say that every microprocessor, it should have two instructions, or it should have instructions in its instruction set which can enable the data transfer to takes place between the input output devices and the microprocessor. So we can say that the instruction set, so it is in the case of every microprocessor will have instructions in its instruction set which enables the transfer of information to an input output device, or to read the information from an input output device. Now here we are studying for the 8086 microprocessor. So 8086, it has two instructions for this purpose. One is the in instruction and second is the out instruction. In instruction, it receives the data from the input device, and out instructions, it sends the data to the output device. So out instruction, it is going to transfer the information to an input output device, and in instruction, it is going to read the information from an input output device. Both these instructions, they are 2-byte instruction. One byte is for the opcode and second byte is for the port number. That is the device which is connected at some port as an input output port. So the address of that port will be given in the instruction. Okay. Now both the in and out instruction, in and out, they are going to transfer the data using the accumulator, because here in the instruction we are going to provide the port address here, means the address of an input port or an output port. So input output port address will be available here. So between the port and the accumulator, the transfer is taking place. So if we have input in instruction, that is the data will be transferred from the port to the accumulator. If it is the out instruction, that is the data available in the accumulator that will be sent to the input output port. Okay. Now in accumulator, this accumulator is the 16-bit register in the 8086, which is denoted as AX. Now this AX, it can be divided into two 8-bit registers. One is AH and second is AL, higher order and lower order. So these are 8-bit registers. So if we want that 8-bit data is to be transferred, then we will use AL register. If we want that 16-bit data has to be transferred, then we will use AX register. So always the transfer of data, it is taking place using the accumulator. So in this instruction, in and out, the port number is specified along with the instruction. Port number means the port address. So port address will be specified like if we are having suppose 10 ports are there. So and input output port we want to use the seventh number. So here we will specify in 07 means seventh number input output port will be used. Okay. Now the address will be decoded. So there is in the microprocessor there is an external input output interface unit which decodes the address of the input output device. So here we have only the port number. Address will be decoded by the external input output interface. Now, if we are using the 8-bit port address, that then will be available on the address bus A0 to A7. Okay, and rest of the address buses they will be at 0. Okay, so the address lines which are used for identifying the port address or the input output port, they will be used, and the remaining address lines they will be kept at 0. Now, as in 8086 microprocessor, we have 20 address lines from A0 to A19. So only A0 to A7 are used for the 8-bit port address. A8 to A19. We have having A8 to A15 also, and then we are having A16 to A19 also. Okay, so A0 to A7 they are used for the 8-bit port numbers. Remaining address lines A8 to A15 they are made 0, and above A15 all the address lines they are undefined for the input output instructions. So up in these 20 address lines only 8 are used. A8 to A15 they are made equal to 0, and A16 to A19 they are undefined. So this will be the case when we are using an 8-bit fixed port numbers. So if we are using 8-bit address, then that will be the that will how the address will be defined. If we are using 16-bit port numbers, then this 16-bit address it will appear at A0 to A15. These address lines will be used, and the remaining address lines A16 to A19 they will be undefined. Now when we are using an 8-bit fixed port numbers, then using this 8-bit address we can address the uh, address will start from 00 to FF. Okay. Now if we are using 16-bit, then the address will start from okay, that will be the 16-bit address, and that is the 8-bit address. So using this we have different numbers of input output ports. So using 16-bit we can address more a number of input output ports, and using 8-bit port addresses we are going to address less number of input output ports. The address range is given here. Okay, so we can use both type of addresses for the input output ports. Now, in this program controlled input output interfacing technique, we are using the in and out instructions. Now, in this type of interfacing also we have two methods. One is the input output map, input output interfacing, because this is the interfacing for the input output devices. So interfacing will be called input output interfacing, and the type is input output map, or it can be memory map. So these are the two types of interfacing methods. This input output mapped interfacing, it is also known as isolated, or we can say direct input output. In this input output mapped interfacing, the in and out instructions which we have discussed earlier, they are used, whereas in the memory mapped input output interfacing, the memory instructions are used. The difference between the two type of interfacing is that in the input output mapping, the input output devices, they are treated as an input output devices only. Okay, they will be work as a separate input output devices, whereas in the memory map they will be considered as a part of the memory. Let us draw a diagram here so it will be more clear to you. Now in 8086 microprocessor, the size of the memory is 1 megabyte. So 1 megabyte, and each register can store 8 bits here. This is also the memory. So the address range of the memory will be 00000, and here FFFFF. Okay, including both the segment address and the offset address of the memory location. So this is how the memory is addressed, and input output devices, they are separate, or we can say isolated from the memory, and they are denoted as a separate device. These input output devices, they are having the size 64 kilobytes, and their address range is from 00000 to FFFF. So here, because both the memory and input output devices, they are isolated from each other, that is why it is known as input output map, or isolated, or direct interfacing. So this is an example of isolated. Whereas in the second case here, the input output devices, they are a part of the memory. So this memory size was 1 megabyte, and this 1 megabyte is shared by both memory and the input output devices. So this is the memory mapped input output interfacing. So that is the difference between the two types of interfacing. Here we can use the in and out instructions, because the input output devices, they are acting separately. So you have seen here that in the memory and the input output, when they are isolated, so input output instructions we can use, like in and out instructions can be used, whereas when the memory and input output devices, they are acting as same, means input output devices, they are a part of the memory. So we are going to use the memory instructions only. Okay, now in this case we have both memory and input output. Memory is completely available to us, 1 megabyte of memory is available, whereas in the second type, the memory map, because input output devices are also combined with the memory, so the total memory available, that is 1 megabyte, that is divided. So total memory size available is reduced. So if we talk about the differences between the two interfacing techniques, then first difference between these two is that in input output mapped, the input output devices, they are placed separately from the memory, whereas in memory mapped input output, the input output devices, they are placed inside the memory. In input output mapped interfacing, the in and out instructions can be used, whereas in memory mapped, the memory instructions are used. Now, in input output mapped, if we want to read or write the input output devices, then we will use the input output read and write instructions. Whereas if we want to read and write from the memory, here we will use the memory operations. So here memory read and write instructions will be used. Now, because in memory input output mapped, both the input output devices and memory, they are isolated from each other, they are placed separately. So overall memory size available is very large, and here means complete memory is available, but here the overall memory size that will be reduced. So entire memory can be used. Here overall memory size is reduced. Next difference we have is, because in input output mapped, this both are separate, so for both we have the addresses will be different. Okay, whereas here memory and output devices, they are same, so same addresses can be used. Also here, because you have seen in the diagram that for the memory size it was 1 megabyte, and input output devices, they are of 64 kilobytes. So here 64 kilobytes means we have the addresses of 16-bit addresses there. The address ranges from 0000 to FFFF, whereas here we have the complete 1 megabyte of memory, so its addresses will be 0000 to FFFF. So that will be the address range. So in the input output mapped interfacing, because we are having the memory and input output devices separate, so we have different signals for both memory and input output. If we want to specify the address for memory, then it will be separate, and the addresses for input output will be separate. So the circuitry has increased because we have to specify separate signals for both memory and input output devices. Whereas in the case of memory mapped input output interfacing, because input output devices, they are same, they are treated as a memory location, so circuitry is simplified. Hardware is also simplified because same signals are used for both memory and input output. So here we can say that in the case of input output map, the circuitry is complex, whereas in the case of memory mapped, the hardware is simplified. Okay, because same signals can be used both for the memory and the input output devices. So these are the differences between the two types of interfacing techniques for the input output devices. In these two ways, the input output devices, they can be interfaced with the 8086 microprocessor. So in this video, we studied about the interfacing techniques for the input output devices. We studied that there are three ways in which the data can be transferred: program controlled input output, hardware controlled input output, and interrupt program controlled input output. Under the category of program control, we studied that in and out instructions are used, and we studied in detail that how these instructions, they transfer the data from or to the input output devices. Then we studied the two techniques which are used for the interfacing: input output mapped and memory mapped. And then in the last, we studied the differences between the two techniques. So I hope that this topic is clear to you. Thank you.